Okay, so we're going to go through rational equations and partial fractions. First of all, a rational equation. When you see a variable down in the denominator, then you know it's a rational equation, if you have a variable down in the denominator. And I'm going to go through and do this by example. You would have solved these in Algebra 2, so this part should be some review. And they will generally just say in the directions to solve. Okay? Leave a little bit of space over here on the left. And say I give you the equation x divided by x plus 4, okay, and then minus 2 divided by x minus 1 equals 20 divided by x squared plus 3x minus 4. Okay? So there's a variable down in the denominator. Most of you don't like the fractions, so get rid of the fractions. To do that, you've got to multiply by the LCD. So first you have to find the LCD. Well, the x plus 4 is already factored. The x minus 1 is already factored. But the x squared plus 3x minus 4, you've got to factor that. There's nothing in common. Then you go to two sets of parentheses. Okay, and this tells you the signs have to be different, 1 plus, 1 minus. They multiply together to give you 4. If that's a minus sign, you say they differ by 3, and this is the sign of the larger one, so it's got to be plus 4 minus 1. Now, once you get it factored, once you get everything factored, you find the LCD. Here's how I say the LCD. Take each prime factor, the greatest number of times it appears in any one of those. So you'd say the x plus 4 appears once, 0 times, once. The greatest number of times it appears is once. So we need it once as a factor. The x minus 1 appears 0 times up here, once here, once here. Greatest number of times it appears is once. So you need it once in your LCD. Okay? You have to be able to find the LCD to work these problems. Okay? Another thing before we start on the problem, you should look at the denominator after it's factored and say x cannot equal what? What's going to make that denominator 0? Yep. So you have to make a note outside before you ever start. X can't be negative 4 because that'd give you 1 in the denominator, and x cannot equal 1. So if you get either one of those answers, you're going to reject them. Okay? Okay, so multiply by that LCD on both sides. Okay. So if we multiply by x plus 4, that quantity times x minus 1. Now, don't just show it on one side. Okay? Your upper level math students, write your workout. Show it on both sides. Bracket or parentheses around the whole thing. You need to take this times this first fraction. Okay, and what I do is I do it by sight. Don't do the slash marks. What divides out is when you multiply that first one out is x plus 4 divides out. But don't slash it out because you still need that whole thing times the second fraction. So if that divides out, what's left is x times x minus 1 minus. Now take that whole fraction times 2 over x minus 1. When you divide that out and multiply it out, the x minus 1s will reduce, but do it by sight, and what's left is this 2 times x plus 4. So you have 2 times x plus 4. Everybody okay with that? You see what I'm doing? Okay. Then equals. Then you have to take this whole fraction times this. Well, these were in factor. This was factored from this. So those will divide out, and the only thing that's left is a 20. And that's the idea, is to get rid of the denominator. Okay? Now you've got to multiply this out. So multiply out x times x would be x squared. X times minus 1 would be a minus 1x. Take a negative 2 times x would be a negative 2x. Negative times a positive would be a negative 8 equals 20. Agree with my arithmetic? Okay, and I get x squared and minus 3x minus 8 equals 20. Get it in standard form equal to 0. Subtract 20 on both sides. X squared minus 3x. If you subtract 20, we'd get negative 28 equals 0. You always want to get it, the quadratics in standard form equal to 0. Then is that factorable? Two numbers that multiply together give you 28 and differ by 3? Yeah. Okay. There's nothing in common all the way across. So then you can go to two sets of parentheses. This tells you when you're multiplying the last terms together, they have to be negative. So one's got to be positive, one's got to be negative. They multiply together to give you 28. They differ by 3, and this is the sign of the larger one. So it's got to be minus 7 plus 4, right? Agree with that? Then set each one of those equal to 0. Okay, either x plus 4 equals 0 or x minus 7 equals 0. So x equals negative 4 and x equals 7. Okay, but up here we said x can't be negative 4. So you have to reject that. Okay, that does not work. So x equals 7, and you should be able to check. If you substitute 7 back in, you'd have 7/11 minus 2. Substitute 7 in would be, 6 equals